So let's talk about making some notes, how it's good to do this. It's like best practices, which of course is not always possible. Sometimes we're just throwing stuff down on paper to get something done really fast. We want to let a student do a lot of examples to practice some concept or method, to memorize something. So we just got to go through a lot of paper, do a lot of examples. Sometimes we're tired and we're not thinking about it. We're busy, whatever. There are certain demands of our time that come up in the real world. So sometimes we're not going to have the best notes, but ideally we want to write down things and use space as much as we have stuff on the page so it looks good and so it's legible and students can read it. And so it's something worth saving. If we talk about don't waste trees, well, why not use paper so it's going to be saved and looked at in the future instead of do a bunch of junk so it's going to be thrown away. You write a bunch of stuff all over a piece of paper and throw it away. That's not saving paper. Saving paper is having something beautiful and worth keeping that'll help someone in the future. So now when we're taking notes, if we want to think about some best practices, we should look at background information, write that down, what we're doing, make some connections to other areas of life and reality and thought, and then draw lessons from what we're doing. When we're going through a lesson, we should put down background information, and that specifically, I mean things that a certain concept or method depends upon inductively to know and understand. Between what we're doing now and what we've done as a baby is necessary to get to this certain point. For example, for calculus, we have to know algebra, the limit process. We have to know geometry, about coordinate systems, how to count, how to measure. Basically that's what we're doing. We're doing a complex process to measure something in the world. Relating back to like balancing something to get its weight, or using a ruler to measure. It's more of a complex process like that. So it'd be something like using a balance to get the weight of something, or using a ruler to measure something's height. Calculus is a much more advanced, sophisticated, abstract version of something like that. Then we can go through the particular concept or method that we're teaching. It's good after that to make connections with other things in human life, other relevant things, make some good integrations of a certain concept with other things. So some concept in calculus, you're doing some differentiation. Okay, how does it come up in biology, in the working of population growth or decay, or how does it come up in blood circulation through the body? How does it come up in movement of water down a river when there's a straight part of the river or creek, or a bend in it, or a log in it? What's happening there? Or of course, how some of the differentials come up in doing some physics, doing some astronomy, seeing how planets go around a sun, or how a moon goes around a planet. It can help us with a lot of that, or how airplane flight works, or car engines work. So we've got a lot of good, relevant causal integrations there, causal connections. And then it's good to draw lessons from it. It's good to draw lessons from it. Things like how measurement shows us how powerful reason is and how we can do things beyond the perceptual. So with calculus and its applications to physics, we can, of course, take someone to the moon, or we can have a little robot that we could send through the body and use for some operation in some really small, delicate place, so we don't have to cut into the body, and we can do a more precise job than we could with maybe doing some of it by hand. Some parts of the brain are very delicate, but if we have a precisely controlled robot that operates according just to the laws of physics, maybe we can be much more successful in it. For a lot of stuff we're doing in biology, of course, biology is the science of life. We should be able to relate it back to our life and how to make it better. So a lot of things we can look at how it relates to the food we eat, what it takes to be healthy, what it takes to have good food, a healthy life, to be strong and active and function at our optimum. What kind of ecology we need, what kind of things we need to grow our food, how we should select it. A lot of that comes into play, and that's, of course, something very important for people to know about. So for notes on something like that, have a lot of background knowledge, inductive knowledge about a certain concept in biology, teach it, then show how it's connected to other areas of life or to different sciences like geology or physics, and then show how it's important. Notes like that give a much better idea to students of how reasoning actually works and how they need to actually learn. It's a lot more rich process than is presented to a lot of people in what they see about science in school. Science in school is just some quick and dirty, bookish, platonic thing. And so people don't really get from that how to do things scientifically in the world and how that's really important for their life. A lot of people think of science as just some kind of la-la thing, divorced from their life, who cares, who needs it, but they're failing to see the importance of it to human life and the fact that it's about cause-effect relationships, which are all around us. So doing notes like this when we can will help. So to sum up and review, remember, write down some background material, what inductively someone would need to know a certain concept we're working on. Go over the concept, that'll usually be the focus. Connect that to other areas of life and thought, and then try to draw some conclusions about reason and logic and life. So for example, if you're studying something in ecology, and you see how an animal or plant fits into all the life around it, the life and temperature and physics and rainfall and hydrology and geology, that kind of thinking is important for building a bridge or designing a house like Falling Water, or doing some advertising or marketing really well. So there's conclusions you can draw from a lot of things that we do. So let's try to do those four things. Make ourselves better, make our students better, and make life better.